Before we go any further, let's talk about evaluating a trig function when the angle is in radians. You find them the same way as when they're in degrees. If you're looking for an exact value, you have to think it through and figure it out from your unit circle. Now, once again, what does exact mean? Because some of you messed this up on your test. Exact means you're not allowed to give a decimal. Okay, so if it's exact, you have to have it in radical or fraction form. So that one most students do pretty well with. You know, they say, oh, just go to your unit circle, whatever. And if you get confused and you're about your radians, if it's on your unit circle, you could use your conversion factor and convert it back to degrees just to make sure you've got it right. So most people do okay with that as long as they remember don't give a decimal. Where people get into trouble is when it's not on your unit circle and you have to go touch one of these three buttons in your calculator: sine, cosine, or tangent. From now on, okay, forever, each time you touch one of those buttons, sine, cosine, tangent, you have to make sure that your calculator is in the appropriate mode. That's the only time you have to change it from degrees to radians or radians to degrees. It's if you're going to touch one of those three buttons, sine, cosine, tangent. If you're not using one of those three buttons in the problem, the mode doesn't matter. But if it's not, if you're using sine, cosine, tangent, you have to make sure it's in the proper mode. So today we're going to look for the first time at something we have to put it in radian mode to do. Are you ready? Okay, let's do some examples. We would like to find the exact values of the sine, cosine, and tangent of 3 pi over 2. Oh, by the way, I would like you to take your unit circles and put them away. We're going to do all of this from scratch as if we're on a quiz or test, okay? So put them away. I don't want you looking at them while we're doing these. So we would like to find the exact values of sine, cosine, and tangent for the angle 3 pi over 2 radians. Now you should have that memorized. How many degrees is that? 270. That's 270. So once you know the reference angle or the reference mark, it's a quadrantal. It's 270 degrees right there. That's 3 pi over 2, 270. What ordered pair goes with that point?
0, -1.
With that angle, right, 0, -1. Once you write down the ordered pair, and that's how I have to think it through every time. I write down the ordered pair that goes with it, figure out where it is, what quadrant it's in, all that good stuff, and then I can answer the questions. Which one of those is the sine? It's the y value, because it's y over r, which is -1 over 1. Which one of those is the cosine? The x, right. And the tangent is found no matter what if you don't have it memorized, and I don't have the tangents memorized for the quadrantals. I just have to look at them. You take the y over the x, so -1 over 0, which is undefined. Remember that 0 on the bottom is undefined. 0 on top is 0. So that's your first example. So now what we'd like to do is find the exact values of cosine 7 pi over 4 and sine of 7 pi over 4. So you have to start over from scratch because that's what's going to happen on tests and quizzes. Best thing to do is if it's on your unit circle, and we know that it is because they're asking us to find the exact values. Find your reference angle first. So your reference angle is 45 degrees because it's something pi over 4. That immediately tells you that the answers are square root of 2 over 2 or negative square root of 2 over 2 because you should associate that reference angle and that something pi over 4 with that ordered pair. All you have to do now is figure out the quadrant. So 7 pi over 4 is in which quadrant?
4.
Quadrant 4. How do you know just by looking at it?
1 less than double the bottom.
If you look at the fraction 7 over 4, the top is 1 less than double the bottom. Okay? So that's the same as 7 pi over 4 is the same as 1 3/4 pi, which we can see is between 1 1/2 and 2 pi. So if you ever get stuck, you can look at it that way. So we do know that it's in quadrant 4. And that will allow me to draw the ordered pair. Positive square root of 2 over 2, negative square root of 2 over 2, and a tangent of what? -1. I don't need the tangent for this one, but the more we write it, the more likely we are to remember it. So let's answer these questions. The cosine of 7 pi over 4 is equal to positive or negative? Positive. We're in quadrant 4, so that makes sense. But the sign in quadrant 4 is negative. Any point on the unit circle. This is cosine. This is sine. This is tangent. Got it? Excellent.
But can't you complain?
So now we're going to look at the tangent of negative 5 pi over 3. Now, right off the bat, you know that the reference angle is what? 60 degrees, because it's something pi over 3. However, negative 5 pi over 3 isn't on my unit circle. So finding its quadrant is going to be an issue. So there are a couple of ways I can teach you to do this. The first is just draw the quadrants and figure it out. Negative 5 pi over 3 is the same as negative 1 2/3 pi. Just convert that to a mixed number, which is about negative 1.6 pi. So if you know enough about fractions, you can count it off. You can start at 0, and you can say this is negative
3 over 2. No.
That's negative half pi. Every 90 degrees is half a pi. This is negative 1 pi, and this is negative 1.5 pi, and this is negative 2 pi. So it works backwards and forwards if you want to count it off. Where would negative 1 2/3 live? Between which two?
1.5 and 2.
Negative 1.5 and negative 2, right? So what quadrant is that in?
1.
Quadrant 1, yeah, it's going to live about right here. So it has a 60 degree reference angle. So that's the same as that point right there. That's the same as positive pi over 6. Is it positive pi over 3, as it turns out. So it's in quadrant 1. Well, once we know what quadrant it's in, we know its tangent. What is it? Positive or negative? Positive square root of 3. So we can answer the question, positive square root of 3. I'm very comfortable with that, but I'm very comfortable with fractions. I don't know whether you are or not. So I'm going to show you another way to do it. Do you want me to pause for a second so you can jot that down, and then we'll look at a different way to do that? And guys, worst case scenario, if you're dealing with some pi's you don't know what to do with, convert it to degrees and go from there. You know, you can always convert it back to degrees, but I'm going to show you a second way. Okay, so let's start back over and look at a second way to do this. Tangent of negative 5 pi over 3. All I know for sure is it has a reference angle of 60 degrees. If I have a negative angle and I'm not sure where it is, how do I fix it? I add what to it? 360. Well, 360 degrees is the same as how many pi's? 2 pi radians, right? So I could add 2 pi to that number. So I could adjust the negative 5 pi over 3 by adding 2 pi to it. Now the problem here is, can you add pi's together? I can. And if you're not sure, you just add negative 5/3 plus 2. Right? Yeah? You're holding a calculator, so you could add negative 5/3 plus 2, right? All right, do it and tell me what you get. Negative 5/3 plus 2.
Negative 1 pi.
Negative 5/3 plus 2. Type it in. Math dinner in there. What do you get? 1/3? You get 1/3. So if you add the coefficients, you get positive 1/3, and that's multiplied by pi. Now, if you do it not in the calculator, which you should be able to do, because we all went to 5th grade, let's erase that. I assume we all went to 5th grade, okay, which is where I learned how to add fractions, maybe even in 4th grade. Where did y'all learn that?
That was
Skipped.
I never
Skipped.
Yeah, skipped.
Every year I hear someone says this. My teacher was like pregnant that year. Every year. My teacher was pregnant that year, and she was out on maternity leave when we were supposed to learn fractions. Somebody tells me that every year. Now I know not every 4th and 5th grade teacher has taken maternity leave in the last whatever, but I do hear that every year. So let's just go back over it. What's the common denominator? Has a common denominator of 3. Well, this guy already has a 3, so his numerator stays negative 5 pi. if I want to convert this to 3, I have to multiply top and bottom by
3.
3. So we put a 3 on top, 3 on bottom, and that makes how many pi's?
6 pi.
Plus 6 pi's. Well, negative 5 pi plus 6 pi is positive 1 pi over 3. So that's the way we can convert it off. So we bring it up to a positive, and now we ask ourselves, what's the tangent of positive pi over 3? Well, we know that that's in quadrant 1, and that the tangent that we have memorized for that point is
Square root of 3.
positive square root of 3. Good. So we could get the answer that way. And if all else fails, convert it to degrees. Bring it up to positive and go from there. Okay? Okay, for example 2C, they're asking you to use reference angles and radian to degree conversions to find the exact value of cosine of 2 pi over 3. I will never ask you to do that. You can do it any way you want on a quiz or test, and most of us know enough not to have to do that. But just in case some of us have forgotten how to convert, let's actually work it that way. If I take 2 pi over 3, what do I have to multiply it by to convert it to degrees? Multiply it by 180 degrees over pi. The pi's cancel, and 3 goes into 180 60 times, and 2 times 60 is 120 degrees. So basically I'm asking you to find the cosine of 120 degrees. Well, my problem is I don't know the cosine of 120 degrees. I just don't. I mean, I still have to stop and think about it and draw it out. This is 180. 120 would be up here. And what would this reference angle still be? 60. We knew that when we started, right?
Yeah.
So that's 60. So the cosine then is negative 1/2 because the ordered pair that goes with it is that. So what's the answer? Negative 1/2. Wouldn't it have been easier if you had just looked at it and said, okay, we know the reference angle is 60 because it's something pi over 3. Because the top is 1 less than the bottom, it's not a full pi, it's 2/3 of a pi. Then it's in quadrant 2. And you could have just written the point. Or you could have just thought the point. You know, you could just think about the point. That would get you there. What's the tangent?
Square root of 3.
Negative or positive? Negative. The more you write the ordered pairs down, the better you're going to remember them. And also remember that on quizzes and tests, if you don't show any work, I can't give you any partial credit. So get in the habit of writing the ordered pair down for me every time. So those are the 3 things that you can get partial credit for. The reference angle, the quadrant, the ordered pair, and then your final answer. So that's how I recommend you talk through all of these.